Welcome to the continuation of Skills Practice 31. We're going to be doing questions 4 through 7. For question 4, we're trying to find the empirical formula of a compound that contains 25.9% nitrogen and 74.1% oxygen by mass. We need to first assume that we have 100 grams total. This means we have 25.9 grams of nitrogen and 74.1 grams of oxygen. Next, we need to find the number of moles of each of these elements. So nitrogen is going to equal to 1.848 moles, and oxygen is equal to 4.631 moles. Next, what we're going to do is we're going to take the element that has the smallest mole number and divide it by itself. We're going to get 1. Then we're going to take the other mole number that we calculated and divide it by the smallest again. When we do this, we get 1 for nitrogen and 2.50 for oxygen. Next, what we need to do is multiply by a common factor to give both 1 and 2.5 a whole integer. So what we're going to do is we're going to multiply by 2 and get nitrogen equal to 2 and oxygen equal to 5. Then we know the empirical formula will be N2O5. For question 5, we're trying to find the molecular formula of a compound that has an empirical formula of NO2 and a molar mass of 138 grams per mole. To first start out, we need to find the molar mass of the compound at the empirical formula level, which is equal to 44.01 grams per mole. Next, we're going to divide 138 grams per mole, which is in the question, by our calculated molar mass of the compound and the empirical formula of 44.01 grams per mole. You should get an answer of 3. The final step is to multiply the number of each element in the empirical formula by the number you just calculated. So the molecular formula will then be N3O6. For question 6, we're told the compound contains 64.3% carbon, 7.1% hydrogen, and 28.6% oxygen. The molecular formula of a molecule has a mass of 448 AMU. For part A, we're trying to find what the empirical formula is for this compound. So first we need to assume 100 grams of the total material, and then we need to find the total moles of each element, as we did in the previous question. We get 5.35 moles of carbon, 7.08 moles of hydrogen, 1.79 moles of oxygen. Next, we need to divide these answers individually by the element with the smallest number of moles. We get carbon to equal to 2.99, hydrogen to equal 3.95, and oxygen to equal 1. Since these numbers are close to whole numbers, we can say that the empirical formula then is C3H4O. For part B, we need to calculate the molecular formula. To do this, we need to calculate the total molar mass of the empirical formula, which is found to be 56.03 grams per mole. Next, we need to divide by the molecular mass in the problem by our calculated answer. So what we're going to do is take 448 AMU and divide that by 56.03 grams per mole. We're then going to get that to equal to 8. In the final step, we're going to multiply the empirical formula by this number to get the molecular formula. So the molecular formula should be C24H32O8. For question 7, I'm not going to go through all the steps of finding each individual number, but we're told that we need to find a certain compound contains 26.35% carbon, 3.30% hydrogen, and 70.35% oxygen. If the molecular mass of this compound is 819 AMU, what is the molecular formulas of the compound? So first what we need to do is find the empirical formula as we did in the previous questions. We find that to then equal to C2H3O4. Next, we need to calculate the molar mass of the empirical formula, which we find to be 91.02 grams per mole. Next, what we're going to do is divide the molar mass given in the problem by the calculated molar mass of the empirical formula. You should get this to equal to about 9. Next, we're going to multiply the empirical formula by the number 9 and get the molecular formula. You should get C18H27O36. And that is Skills Practice 31.